Hi, I'm Teacher Thomas. Welcome to math class. This is lesson 2 on the topic series. Today we will be learning about geometric progressions. In the previous lesson we looked at arithmetic progressions in which we see a constant addition to each term. With geometric progressions we see a constant multiplication from term to term. Two formulae that we'll need for geometric progressions. One is the nth term of a series, a times r to the power of n minus 1. Labeling the components of the formula, a is the first term, r is our ratio, this is the multiple, and n is the number of terms. Looking at our second formula, the sum of n terms, a times quantity 1 minus r to the power of n, over 1 minus r, also using a, r, and n. We'll work through two sample problems. One, the third term of a geometric progression is 144, and the common ratio is 3 over 2. Find the seventh term and an expression for the nth term. To use the nth term formula, we need to know the first term. So let's start with looking for the first term using the fact that the third term is 144. So the nth term, to begin, will be the third term. 144 equals a, that's our unknown, times r, the ratio is 3 over 2, to the power of n minus 1. In this case, we're setting a 3-term series, so we will have an exponent of 3 minus 1. I'll put my 3 over 2 in brackets to apply that exponent to the entire value. This simplifies to a equals 64. Now the seventh term equals a, we know, is 64, times the ratio 3 over 2 to the power of, looking for the seventh term, 7 minus 1, which is 729. For the second part of the problem, we're going to replace the 7's on the left and the right with n. So the seventh term, now I will write the nth term, equals 64 times 3 over 2 to the power of, instead of 7 minus 1, n minus 1. Let's go to problem 2. Find the sum of the first 10 terms of the geometric series 2 plus 6 plus 18 plus 54 plus going on through 10 terms. We'll use the sum formula, solving for sum of n terms equals, we have a fraction, a is our first term, that is 2, times 1 minus r we need to calculate. Looking at our given terms, 2, 6, 18, and 54, we can see that from 2 to 6, we multiply by 3. From 6 to 18, we multiply by 3. Same for 18 to 54, so our ratio is 3. Back to our sum of n terms formula, 1 minus r, 1 minus 3 to the power of n. n in this case is 10 terms. In the denominator, 1 minus r, 1 minus 3, which results in the value of 59,048. This completes the requirements for problems 1 and 2, and this completes the lesson on geometric progressions.